We are from Group 10, Part 2, AS120, Diploma in Science from UiTM Tapa. So in this video, we are going to present our MAT183 Calculus 1 video presentation regarding the techniques of differentiation. So before we begin, what is differentiation? Differentiation is a core concept in calculus where it is used to find the instantaneous rate of change. This means it is used to find the slope of a line on a single point of a curve. So there are several techniques of differentiation, such as product rule, where it is used to find the derivative of two functions multiplied together. And then we have quotient rule, where we use it to find the derivative of one function divided by another function. And then we also have chain rule, where the derivative of a function is inside another function. And then we also have implicit differentiation, where we differentiate without isolating y first and then treat y as a function of x. And lastly, we have linear approximation, where we estimate a function's value near a known point using a tangent line. So each rule is applied depending on the structure of the function given. So now let us proceed to the next question.
Hello everyone, my name is Abdul Harith Abdul Rahman and I'm going to answer the question 2. For the question 2a, the function is y equal to ln x squared plus 1 cos x plus 1. First, I identify the type of differentiation technique. This function has two functions multiplied together, which is ln x squared plus 1 and cos x plus 1. So I use the product rule. Then I let u equal to ln x squared plus 1. V equal to cos x plus 1. First step is I differentiate the u. When I differentiate ln fx, it will be f prime x over fx. Here. Then I differentiate x squared plus 1, becoming the 2x. So the du dx is equal to 2x x squared plus 1. The second step, I differentiate v. I got cos x plus 1. When I differentiate cos, I get negative sine fx multiplied by f prime x. X plus 1 differentiate to get 1 equal to negative sine x plus 1 multiplied by 1, which we get from here. And then I simplify it, becoming the negative sine x plus 1. To get dy dx, we need to use the product rule formula, which is uv prime plus vu prime. I substitute all of the information I've gathered to get this equation. After we simplify the equation, I will get this equation. For the question 2b, the function is y equal to tan fx over 1 plus x squared. So for this question, I notice the function is one function divided by another function. So I use quotient rule. Now the next step, I let u equal to tan 4x and v equal to 1 plus x squared. The next step is I differentiate u. When I differentiate tan, it will become secant square, and 4fx I will get 4 is equal to 4 secant square fx. Differentiate v. V equal to 1 plus x squared. Then we will get the dv dx, which is 2x. And then to find the dy dx, I use quotient rule. Then I substitute all of the information I've gathered into the equation, and I will get this one. After I simplify all of the equation, I will get this final answer.
Alright, hello everyone, my name is Rajesh Zafri and today I will be showing you how to solve this question using implicit differentiation. Alright, so why we use implicit differentiation for this question is because the variable y is mixed with the variable x and is very hard to isolate. Alright, so first we have to differentiate both sides. We're going to start with ln y. So the derivative of ln y is 1 over y, and then we have to multiply it with the differentiation of y, which in this case is 1, and then every time that we differentiate y, we have to multiply it by dy dx. So the derivative of cosine is negative sine, so we just write it, and then we rewrite the expression inside of the bracket. Alright, and then we have to multiply that with the differentiation of the expression inside of the bracket, which the derivative of x squared is 2x, and then the derivative of e to the power of y is e to the power of y multiplied by the differentiation of y, which is 1 times with dy over dx. And we can go to the other side and do the, so for the 2xy squared, we have to use product rule, right? Alright, so for the product rule for the 2xy squared, we're gonna use the formula, which here we have 2x, and then we're gonna have to time that with v prime, which is 2y times with dy over dx, and then we have to plus v, which is y squared, times with 2. And then we would get 4xy times with dy over dx, and then plus with 2y squared, and then we can expand in the brackets. Alright, so after we have expanded the equation, we have to move all the dy dx, the terms containing the dy dx, to one side and the rest to the other side. Alright, now that we have separated the dy dx terms, the rest of the terms, now we have to factorize the dy dx. Alright, so now that we have factorized the dy dx, we can move the whole expression inside of the bracket to the other side by dividing it. Alright, so this will be our final answer. Okay, so to conclude, my recommendation to solve this question, or any question involving implicit differentiation, is for you to first master all the rules and techniques of a differentiation. Right, so that's all from me. I'm gonna have my friend take over from here.
Hello everyone, my name is Muhammad Qasim, and today I will solve the question 4 about a linear approximation. But the linear approximation of fx at x is equal to is given by this formula. And then let's jump to the question. As the x given is a x.02, and x now is the closest number of the x given, so I will choose 8. And we need to find the chance of x. The chance of x we can find by this formula, x minus x null, and the chance of x we get 0.02. So let's fix the equation. We get x squared minus x to the power of negative 1 over 3, and after that we need to differentiate this function to find f prime x, and we get 2x plus 1 over 3 minus 4 over 3. After we get this, we can insert this equation to the formula given, and after we calculate all the number here, we will get a final answer. This is the final answer we got. To wrap this problem perfectly demonstrate the power of a linear approximation using calculus. Instead of dealing with complex decimal places and trying to calculate 8.02 power of 2, it will be much more easier if we used tangent line of the function, because x is very close to 8.02, so the rate of change of the exact point given, it will be highly accurate. This technique highlights a fundamental concept in mathematics, how calculus allow us to simplify complex equations to a simpler one. That's all from me. Thank you.